question here on hypothesis testing. The established fact is that 25% of adults in a large population have a particular allergy. Ryland believes that the actual proportion differs from 25%. Random sample of 50 adults from the population, he carries out a test of the null hypothesis, which is that the probability of someone having an allergy is 0.25, using a 5% level of significance. Our first question is write down the alternative hypothesis for Ryland's test. So let's analyse this a little bit. The established hypothesis is that 25% of adults have an allergy. So we can say that H0, the null hypothesis, is that the probability of someone having an allergy is equal to 0.25. Now, what's he saying? He's not saying that the population of adults having an allergy is less than or greater than 0.25. He's saying that the probability is just different from 0.25. So his hypothesis, his new hypothesis, H1, is that the probability is not equal to 0.25. And that's the answer to part A. So in part B, we've been asked to find the critical region for this test. So what distribution have we got? People either have an allergy or they don't. So the random variable x can be described as it's a binomial distribution. He's taken a sample of 50 people, and the probability of anybody having an allergy is stated as 0.25. This is the null hypothesis that would create a binomial distribution such as this. This is what should happen. Now, it should be clear from part A that we're dealing with a two-tailed test. So if we're testing this null hypothesis at a 5% significance level, this means that our significance level at either end of the test will be 2.5%. So to be in the critical region at the lower tail, we would have to find a probability of 0.025. And similarly, at the upper tail, our probability will be 0.25 away from 1, so this will give us a probability of 0.975. So we need to use the calculator to find a value of x that puts us into the critical region at both the lower tail and the upper tail. And we'll need to use the cumulative distribution function on the calculator to get those answers. So let's first bring up binomial CD. This is option 1. And hitting 2, our variable brings up our list. Now, this is effectively the answer we want. So we're going to have to guess an answer here. Out of 50, let's guess an answer of 8. 8 people. 50 is our sample size and the probability 0.25. So this will be the probability of 8 people having an allergy, 0.915. So we're well outside our value of 0.025 here. We've got to reduce our value of 8. Let's try 7 and see what we get. 0.045, where we're getting nearer, but we need this to be 0.025. So again, let's try reducing the value of x. Put it down to 6. And 0.019 results. This is nearer to 0.25 than our previous answer. So 6 will be our lower tail answer for the minimum number of people to have an allergy that we might challenge the null hypothesis because we are in the critical region if only 6 adults are found out of 50 to have an allergy. So let's write that down. So let's do the same now for the upper tail. Again, we have to guess the answer. let's guess at 40. And remember, we're after an answer of 0.975. And as you can see, we're way off. Probability is 1. So let's reduce this to 30. We're still massively high. 20. 0.9937. We're getting near, but we're still effectively in the critical region. We need to find one of the values which comes out of the critical region. In other words, below 0.975. Try again. Let's try 19. Still in the critical region, but getting really close. 18. And now we've dropped outside the critical region, 0.9712. Do remember that this answer of 0.712 is the probability of x being up to and including x. X is less than or equal to 18. Let's write these results down that we've got, which are either side of just into the critical area and just out of the critical area, and work out what this actually means in terms of the 2.5% significance level. But we need the probability of x being above this number. So we need the probability of x being greater than or equal to 19, which is the next number up. And this will be equal to 1 minus the probability of x being less than or equal to 18. And this, if you work it out, take this number away from 1, you get 0.0287. Similarly, using our figure down here, the probability of x being greater than or equal to 20 is equal to 1 minus the probability of x being less than or equal to 19. And again, if you work that out, we get 0.0139. So we still need to answer part B. It's not asking us for the values of x that gets us into the critical region. It's values of x which gets us close as possible to 2.5%. So the answers are going to be this one here and this one here. So the critical region is from x is less than or equal to 6 and x greater than or equal to 19. So the critical region is defined by values of x getting as close as possible to the 2.5% significance level at either the upper tail or the lower tail is x must be less than or equal to 6 or greater than or equal to 19. So part C, state the actual probability of incorrectly rejecting H0 for this test. Well, this is simply found by adding up the probabilities we actually got, which got us closest to the requirement of part B. So all we've got to do is add these two numbers up. And this comes to 0.048, which is your answer to part C. Part D says that out of the sample of 50 adults, he found that 10 in his sample have the allergy. What's his conclusion to his hypothesis test? Well, 10 is not in the critical region. So we have insufficient evidence to reject the null hypothesis. And here's that statement written down. With x is equal to 10, which is the results he found, we have insufficient evidence to reject the null hypothesis. And that's the answer to part D.